So with this autonomy, there is a lot of risk involved. So we have the human in the loop to approve, or disapprove the actions of the agent. But there are also, vulnerabilities in these tools that we need to be aware of. So we can try and limit the damage that is done by using these agents. So first of all, we'll talk about local models. So Gemma 4 is a local model from Google, and it's based on the Gemini LLM, and it basically has open weights. So that means that it's open source and it's free, and it's designed to run on your own hardware. They've released multiple different sizes of this model. So there is one for a mobile phone, there's one for a laptop, there's one for a server. So essentially, it's a local model, so you can download it and you can have the power of Gemini essentially local to your machine, so you don't need to even have the internet. And there are loads of different benefits that we're going to look at here. So the first thing is complete data privacy. All the processing happens on your machine, so client data, financial records, any sensitive documents that you have won't even leave your machine, never mind leave your network. So you have complete data privacy. There are no per token charges, so once it's downloaded, the model runs for free. So it's ideal for high volume repetitive tasks, and the only cost is the cost of it running on your machine. So your electricity costs. It meets GDPR regulatory compliance, and things like data residency and sector specific requirements. You control exactly where the data is processed, so everything is all above board in terms of GDPR. You work without the internet, so it's critical for, or can be critical for air-gapped environments, remote locations, or unreliable connectivity. So even you hear of people using these models, downloading them onto their computer and using them when they're flying, for example, when they can't get connected to the internet, but they still want the ability to be able to have access to a chatbot. You can fine-tune the Gemma 4 with your own data. Now that takes a bit of technical know-how, but essentially once you train it with your own data, it becomes more specific to your domain, and even things like terminology that you may be using and the processes that you're using. And of course, it's open source, so you can inspect, audit, and modify the model. So there's no vendor lock-in at all, and any improvements are community driven, so it's quite transparent. You can see the weights are open and the code itself, so you can even retrain the model if you want. You can, like I say, it can be fine-tuned as well. There's loads of different things that you can do, so you can modify it in whatever way that you want. It's completely open source, so it's free, and it means that you don't have any limits or anything. But there is a trade-off, because these local models are usually smaller because they're running just on your normal GPU or your normal CPU. They're best for just focused, well-defined tasks. Another thing we will talk about in terms of trying to be safe with these agents is having some when the agent is executing, to basically have it in a sandbox environment. So what is that? Well, Docker is a product where they have Docker Sandbox. It's basically an isolated small computer that is running on your host computer. So essentially, if the agent makes a mistake or it runs any dangerous code, your actual system is completely protected, so it can't destroy your system. Why would we do that? Well, if the agent can't access the host file system, then it's completely isolated. It can't do any damage to our files. Any bad code can't damage our system. We can reproduce the environment. We can get the exact same environment every time. With Docker, we're allowed to limit the network and the resources that the sandbox is using. So things like the CPU, we can limit the memory usage, that it has. It's a disposable thing, so these containers, you can basically destroy it and then recreate it at the click of a button. And with Docker, we have full logs of what the agent is doing, so we get that automatically. We have this audit trail, and only in terms of accessing the internet, only specified websites can be accessed. So there will be, if you look at this diagram here at the right hand side, we essentially have our host computer here, and the Docker container is a separate computer that is running on top of your computer or inside your computer, but it doesn't know about your host file systems. So it only knows about what the host allows it to know about. And then likewise, when it's trying to access the internet, we can specify exactly where it's allowed to go, and it can't go anywhere else. So in that way, we can put in layers of security, and we can stop, even if a hacker got into our sandbox, then they wouldn't be able to get anything back out because we would have the network basically locked down. And if anything did go wrong, we could just delete the sandbox and create another one again at the click of a button, and everything would be back to normal again. So essentially, the local model would run inside the sandbox, and then the sandbox runs inside your computer. So when we have this kind of segmentation, this separation of these environments, then that makes it a lot more safe. So the agent can run whatever code it wants in the sandbox. It can't do any damage beyond that. And if it does damage it, then we just delete it and we create another one. So if you wanted to go for a full agentic architecture, let's say you're a small business and you wanted to start to get this architecture together, so then you could just give one of these chatbots a simple prompt and let it work for a couple hours or however long it takes, and then just come back then and it would have the result. So first of all, we want to start with the local model. So the Gemma 4 are a pretty good local model. This is essentially the brain of the system. So this will run on your hardware. So that means that no data leaves the premises. So therefore you're GDPR compliant by default, and it's completely free after you download it. So like I say, the only thing that you're going to be using is the computer that the model is running on, the electricity essentially just. The Docker sandbox then, that's essentially the safety net. So this will isolate the execution of anything that the agent's doing. It will protect your system, and it is a reproducible environment which we can destroy or we can create at a moment's notice. And also there's a full audit trail along with the sandbox, so anything that the agent is doing, that will be logged, even its thinking and everything else, all of that will be logged automatically. The next thing you need is an agent harness. So this is essentially the thing that is going to manage the agents.md configuration, that's going to manage the observe, think, execute loop. There are different ones. The Claude Code is a pretty popular one at the moment, but you should be aware that most of the good agent harnesses, they cost money. So this is when we're looking at this would be a business that wants to scale up these agents. So when they would basically be able to create loads of different agents and have them interact with each other, and then this is where you can connect the skills and the tools and things like that. So the MCP servers, and that would be the next thing. Then you would start to connect all of the MCP together. So connect, for example, your email or your calendar or whichever it may be, the database or your file system. So this would be the basic architecture to try and make sure that all of your data is staying locally, but you're using the power of the agent harness, and it being able to connect to the MCP servers, and basically be able to, your model can talk directly to your email or directly to your file system. So if you had this architecture, you essentially would have a goal in, then the model would start to reason locally. You would need to run the model locally, and then the sandbox would execute everything safely. The harness would orchestrate all of your different agents, and it would also connect the MCP tools to the agent. And then once you have all of that pipeline, it's basically goal in and result back out. So a business that really wanted to start thinking about putting this into action, there's a couple of things I would advise you to do. First of all, download and install a tool called Ollama. This is basically a user interface for interacting with the Gemma 4 models locally. So once you have Ollama, then you can pull down Gemma 4. Docker Desktop is a good one as well for the Docker sandboxes. And then maybe try an agent harness like Claude Code and try and run your first agent task. So whether it is, drafting emails from your email inbox or whatever it may be. Then later, what you may want to think about is looking more into Docker sandboxes, starting to look at configuring your different agent files for your different agents. So remember, it's best to have one agent is good for one specific task. Connect all of your tools to the agent, and then try and automate one real workflow and see was there any time saved. Try and measure that. And then if you want to start, implementing it on a more long-term basis, then start thinking about building the full architecture. Train your team on the workflows and try and automate, maybe 5 or more business processes, and start to look at the return on your investment, and then, share your results and your good stories as well. So start with one simple workflow, and the goal is really at this stage to understand this observe, think, execute loop before trying to scale it to complex multi-agent systems, because you really need to walk before you can run, and these things are becoming a really powerful tool. So you do need to be careful when you're scaling up with these. Okay, thanks for listening. There's a few action items that you may want to try if you are serious, about learning agents and starting to get used to agents. It really is the new paradigm shift in the whole AI field in general. So I think that this is timely to have this session, and it really will be the future. The novelty of using the chatbots, I think, is starting to leave us, and we're starting to see that the productivity gains really is when we can basically take the human more out of the loop in terms of the manual tasks that we need to do, and put the human more as an orchestrator, more as the person that is building these agents together and making sure that they are doing exactly what they're supposed to do. So the human is becoming more of the conductor of the team, and then basically they're going to delegate out to all of these agents, and then all you have to do is review your team's work. So that becomes a less onerous task on the human overall. Okay, thanks for listening, and keep in touch with the course, because we may be adding to it. As this field does grow, it is changing all the time, so we may be adding more stuff as things progress.